Good morning, good afternoon, or good evening. This is Mr. Parks back with another video for homework help for 6th grade for lesson 1.2. So for today's lesson, we were talking about prime factorization. We need to know two important details to help us do this lesson. One of them is what a factor is. So our factors are numbers that we can multiply to find a product. So for instance, this larger number here is going to be a product. We're going to try to find the numbers that we can multiply together to get there. But the other part of this, all of our factors need to be prime numbers. They must be numbers greater than 1, whose only factors are the number itself and 1. So for this first problem, we have what is called a factor tree. And our factor tree lets us kind of split this up into smaller pieces. We'll find out the factors we can multiply together to get to these larger products in just a moment. So what we're going to start with is the number 18. They give us part of our factor tree. I would ask my students from here 6 times what number gives us 18. And so after a few seconds, hopefully most of them will have the answer. It should be 3, because 6 times 3 makes 18. We have an extra line here. We're just going to go ahead and carry that down to the bottom, because we already have a prime number. So this number is done. We could even go ahead and write it down here on the line. Now we need to find what 2 prime numbers we can multiply together to make 6. And so those 2 numbers are the number 2 and the number 3. And then we can copy these down here. We now have our prime factorization written for this problem. Okay? Many of the questions on the homework tonight will be something similar to this. It's just, do you prefer doing the factor tree, which I see a lot of, or do you prefer this, which I refer to as a ladder? We're trying to make a series of division problems. So to start with, we would actually be trying to solve this long division problem, but we are going to write the number we divide by here. The answer would go down here. So our quotient when we're done is going to go inside this box. So if we follow through our steps, I'm going to skip a couple steps for time's sake, we would end up with the quotient 21. That needs to go in our blue box here. And then it's got us set up, we want to do 21 divided by 3. Our quotient is 7. We need to figure out what prime number we can divide 7 by to get to 7. And since 7 is already a prime number, we can write our 7 on the outside. We do 7 divided by 7 equals 1. And that finishes our problem. We just need to take the 2, the 3, and the 7 and write them down at the bottom. So just to give you an idea of a couple numbers we might be working with for this lesson, I'm going to kind of put this out to the side. We're going to end up working with 2, 3, 5, 7, 11, and 13. We might go even bigger than this, depending on what problem we're working on, but these are like the first 6 numbers I try to ask my students if they can divide by and get a whole number for the answer, and then if we are able to do that, and we're able to, let's say we do 4 divided by 2, that tells us it's a composite number instead of a prime number, okay? So one of the things that we'll do if we're doing this is we're trying to guess numbers that we can plug in. So these are the first kind of 6 numbers we can try that with. I'm going to go ahead and scoot the page down here real quick, and we're going to take a look at a couple of the problems from later in the lesson that are going to have something similar come up on the homework. I'm going to start with number 16. So number 16 says, Danny says she's thinking of a secret number. As a clue, she says the number is the least whole number that has 3 different prime factors. So we want to know what the secret number is, so I'll leave a little blank for this. And then we need to know what its prime factorization is. So we are going to write out the multiplication problem using only prime numbers that we can use to get to this answer. So going back up to our list for just a moment, our first 3 prime factors are 2, 3, and 5. So I would ask my students to look at that list, come up with our numbers, and I'm going to actually write out the prime factorization first on this side. 2, 3, and 5. And now I would ask my students to multiply those numbers together. So 2 times 3 makes 6, 6 times 5 makes 30, and that would give us our answer for the other portion of the question. All right, and then our other problem here, we are looking at finding the area of a rectangle, area of rectangle is given to us. We're trying to find the width. So we don't yet know what the length is, but we know what the area is. And we know that the width has to be a number that's larger than 10 and has to be a prime number. So the first thing I would ask my students to do is, well, let's figure out what the first prime number is after 10 and see if it goes into 260. So if we tried that step, it would start like this. I'll give you a few moments if you want to try to figure out the answer for yourself. Go ahead and pause the video if you want to work through this. I am going to go ahead and stop. I'm going to count backwards from 3, and then I'm going to go ahead and tell you the answer. So 3, 2, 1. This will not work. 11 will not go into 26, and if we try to work through our steps, we're going to end up with 22 here. We subtract to get 4, bring down our 0, and 11 will not go into 40 evenly. We would have a remainder. So 11 will not work. However, the next thing I would try would be 13. And if we do 13 going into 26, we will find that that does in fact work. So we can actually multiply 20 times 13 to get to 260 by doing that division problem. But since we're only asking for the width for this, that would be 13, and we should use inches or abbreviate. So I'm going to do the abbreviation just to save a little bit of time on the writing portion. Okay? So now let's take a look at the actual problems from the homework so you can see what we are looking at doing. So for the first section, yes, they model using the factor tree. I'm going to tell my students, you do what you are most comfortable with. Factor tree usually works well for most people. Do it on a separate sheet of paper, staple to your paper, or write your name on it, turn it in with your homework paper if you're one of my students. Probably, if you're watching this from another location, your teacher might ask you to do the same thing. So please make sure to show your work, because if there's a mistake somewhere, we want to know how we can help you, okay? So that first section is going to be all of that. Number 7, a computer code is based on the prime factorization of 160. So they want you to find the prime factorization. The difference between number 7 and number 8, because number 8 is also asking for prime factorization. Number 8 gives you specific directions for how to write the numbers, okay? Number 7, find the prime factorization. You can write the factors in any order you want. But for number 8, they want the factors written from smallest to largest, least to greatest, okay? Number 9, describe 2 methods for finding the prime factorization of a number. Hint. It's one of them has to do with this picture. The other one has to do with using the ladder, okay? So if you watch that part of the video, you can put into words how to use both of those pictures or models to do that. On the back, exactly the same kind of things that we've already talked about. We have a couple different puzzles we need to solve. The one on the left here for number 10 says it's the product of 2 consecutive prime numbers, okay? So we need to know what the pin is. So once you find 2 consecutive prime numbers that get us up to this range, we want to know the product here, okay? You're going to be working with some larger numbers. So it's going to take a little bit of time and a little bit of experimentation to try to figure out the range that you're looking for, okay? So keep that in mind. Number 11 is a little bit more simple in that you are going to end up finding 6 digits that are the 6 prime numbers that we can multiply together to get to 5005. And if each digit increases from left to right, we want to write it from smallest to largest, okay? Number 12 and number 13 are easy enough, but a couple things to think about. Our expression for number 12 is the math problem, or math problems, because it's plural in this case, that we can use to find the answer. So if we are paying $15 for a piano lesson, which is actually pretty decent price as someone who is a musician, that's actually pretty decent. I would like to be able to get piano lessons for $15. I think it costs more for that when I was a kid than it does in this problem, and that's great. How much would it cost to do 5 lessons? So there are 2 types of math problems we can do to find that. We need to write both of the math problems that would give us what our total amount we would spend for 5 lessons would be. Number 13, place value. We need to write the complete place value for the digit 5. Okay. Number 14, we need to order or sequence these numbers from least to greatest. And then our final one, we are taking 312 pages and we are splitting it up, reading it across 12 days. That means we are going to divide. Okay? That means this is probably going to go in evenly. If it doesn't, ask your teacher for what they want you to do if there's a remainder or if there's a decimal. So remember, in 6th grade, we're going to expect that you hopefully remember division with decimals from 5th grade. So if it's one of those situations where you're writing a fraction or you're writing decimals, hopefully you remember how to do both of those. Check with your teacher to find out which one they want you to do. So that concludes our video for today. I hope it is helpful. I know it's a little bit longer, but I wanted to give you guys a chance to also see a couple examples and quickly talk through what the actual problems on the homework page look like so you have an idea of what to do. Have a great day. I hope this is helpful for you, and we will see you on the next video.